Hi guys. So today I'm going to talk a little bit about a problem that we're trying to solve with integration testing with Selenium. It's a common problem that a few people have come to me with lately about how do I have a more reliable way of testing Selenium without some huge infrastructure like a Selenium grid or something stood up. So I'm first going to start with a little bit about the problem. So the core problem that we're looking at, right, is the integration testing with Selenium. How do we do it, right? What we need to make sure, though, is we've got something that's both repeatable, reproducible, reliable. This is something that gets quite hard with Selenium because there's multiple different browsers, platforms. I'm just going to look at Chrome today, but what we're doing today, you could easily expand to other browsers as well. The other thing we need to deal with as well is that developers' locals are usually Windows or Mac, and then our CI is Linux. So we've got a lot of different platforms to deal with here. So getting reliability and repeatability between them is sometimes hard. So there's two different ways to do this that I'm going to talk about today. The first way is using your IDE to debug. Because you essentially have code that will interact with Selenium. You'll want to debug it. You'll want to take advantage of step-through debugging, find out what's going on, get in the internals. You don't want to debug Selenium itself, but the tests that you're writing and things like that, you'll definitely want to get in there with some breakpoints and debug something at some stage. So the way that we're going to look at doing that is essentially running the code inside of the IDE and then connecting to a Selenium container that's running from a Docker Compose. So this would involve the developer themselves writing a command in the command line, running it, and then debugging from their IDE. The next thing that we're going to look at is just doing everything from the command line itself. So essentially taking the same code that you were running in your IDE and putting it inside the Docker Compose as well to run. The reason that we've got this second method of doing things is you're not going to have a UI IDE on a build agent to run things. It's going to need to be driven by a command line. So this second part of it, we're going to try and reuse as much of the code as we can. Some mistakes that some engineers usually make is they end up creating a Docker Compose for this, a Docker Compose for that. But Docker Compose, you can actually compose. So we're going to look at how we can break up our Docker files so we can make them into reusable pieces that we can compose based on the scenario that we're doing for less maintenance. So that we're not copying and pasting YAML everywhere. And so that essentially puts the code and the test run itself inside the same Docker Compose sandbox as the Selenium and runs it all isolated. So we'll start with the first one. So here we've got our integration test project, and we've got two Docker Compose files. So we'll start with the Selenium one first. So this one we can see here, it's a pretty standard Docker Compose Selenium. We're using the standalone Chrome container. This one's important. It's a nice little isolated container we can use. I should make a point though, make sure you match the version of this that you're using with the NuGet package that you're using as well. So here we're using beta 2. If we have a look at our NuGet packages in the project, we'll see that they're beta 2 as well. Beta 2. There we go. So the other side to our Docker Compose is we've got a second Docker Compose here, which is our integration test file, which we were talking about before. So the having multiple Docker Composes. So you can see this one here only has the Docker file for the integration test project, and we can see inside the integration test project here, we've got our Docker file. So the concept here, and this is a multi-stage Docker file, so when we run the Docker Compose up, it's going to run the commands in the Docker file that essentially build and run the test. So this will compile the code for you. And then we're also here passing in the Selenium hub URL as an environment variable that our tests will pick up and know that it has to talk to Selenium. The reason we have this Selenium DNS here is due to Docker Compose. You can see this guy here is called Selenium. So Docker Compose does this lovely thing of putting host file records in, so you can refer to the containers by their name to resolve the DNS internally within the Compose. So first we're going to try and run just with the IDE. So what I'm going to do is a Docker Compose up --build. So --build just make sure it's going to build the container. So what this is going to do, because I haven't put any -f commands in, it's only going to use the Docker Compose and the Docker Compose override, but our Docker Compose override is empty. So it won't use any of the other Docker Compose files. So the important thing about this is we assume that your the development path is going to be this one that the developer most commonly uses on their local. So this is the command that people will type in the most. So we make sure that the command that people type in the most is the one that's the shortest. Okay, so go back to my command line. So if I run him, so this will start up just our Selenium container. And we'll see here it's running, it's listening on port 4444. So we can now go into our, now one thing I'll show you is that here we've got the Selenium hub URL configured to use localhost. So because this is running on our IDE, it's not inside the Selenium sandbox, so it can't resolve that unique address Selenium because it's running in the IDE process, not in the Docker Compose. So we have to use localhost here, and we've exposed that port out the NAT from the Docker sandbox. So what we can do here now is our integration test project. So now that it's running, what we want to do is come in and debug this one. This is our integration test, and I've set a breakpoint there around the where it's initializing the driver, so we can have a look at some things. So you can see this is my hub URL, it's localhost. This is going through the NAT into the Compose, and then it successfully created a driver, and it's going to go and issue some commands after this. And if we have a look back in the log output from the Docker container, you can see there's a bunch of extra log output now because the Selenium instance has been hit from our test, and our test has said, you can see here it's session requested, desired capabilities, browser name Chrome, and so on. So this is a bunch of information about the kind of browser that we've requested. And I'll do a little blog post about this as well, because there's a whole bunch of default options you need to ask for Linux to work in a Docker container, for Chrome to work running on Linux in a Docker container. It's not straightforward and doesn't work out of the box, and the documentation is not too great. So, so yeah, you can see he's finishing up there and he's waiting for some commands. So what we can do is just come back in here, let him go. I don't think I've got any other breakpoints, so that should just finish, and the test should be successful. Yep, big green. So, the next part. So, the next thing that I want to demo is how we apply that to CI. So this guy's still up, and he'll just sit there, and you can continue to debug while he's in the background and continue to use him on your local if you need to. But I'm going to hit Control-C and then tear this down. And then what we're going to do is we're going to try this, but doing it on the local. Now, so the next one we're going to try is this one. So the Docker Compose command line standing up the tests inside the container with the Selenium group. So what we want to do is, so this is him running on CI. Now, this command, which is also running on our CI, you can see as well, is quite long. And so this is one that developers probably won't use on their local. They'll probably use it quite rarely when they're trying to debug issues. Why is this working on CI and it's not working on my local or something like that? So this one's quite long, and you can see it's using the -f directive. So if it uses -f, it won't default to using the Docker Compose or the Docker Compose override. It'll only use the files that you pass in. So we're passing in to use the Docker Compose integration and the main Docker Compose, the -- build again, but now we're doing on abort on container exit. This is because essentially, when the unit test project or the test project has finished its run and it exits, you actually want to exit the whole compose. And this is how it works on the build agent too. I see a lot of engineers, what they do is when they're using Docker Compose on the build agent, they'll do a Docker Compose up, wait, sleep for 60 seconds, run their tests, and then sleep for 60 seconds or something, and then do a Docker Compose down. If you use this abort on container exit, everything comes up through the Docker Compose and everything's torn down through the Docker Compose. So it becomes a single command line. You don't need to do your Docker Compose up and down before and after. So I'll execute here. And then we can see it's coming up here. So it's starting the Selenium container, but this time as well it's also starting the integration test container. And we can see Selenium starts up again the same as before, but we're about to see a bunch of log output come from the test container. And this is it initializing the browser, getting the config from the test project again. Yep, and here we go. So test pass. And now it tears itself down. So we don't have to do the Docker Compose down, it does it for us because it understands the project's finished. Now you can also use loggers in here, like your TeamCity logger or your GitHub logger, to output the textual format that the CI systems can parse, just like a normal command line. So you can get your test output information in your CI system fine. Here's an example. So this is basically an exact replica of what's happening on the build agents as well. And the brilliant thing about this, and you see total test pass down there, yep, is this will work on Mac, this will work on Linux, this will work on Windows, all the same. Now the IDE is going to be a bit different, but there's not much we can do about that. It's a UI that's custom built for the platform that you're running on. But at least we know we've got a Docker Compose at least that's being able to run on each environment. And also in summary, you can see that we're composing the Docker Compose. So I haven't created a Docker Compose file that's got everything it needs for integration testing, and then a Docker Compose that has everything that it needs for local. It's a composition of the different files. So this way you're not copying and pasting things. And it becomes easy to maintain these things. Yeah. So I hope you enjoyed the video, guys.